Okay, so let's start. किसी को कोई specific problem है क्या continuity में, या फिर you should do it from the beginning? हाँ.
Can you do convergence before starting?
Okay, so you want us to discuss convergence first. अच्छा ठीक है. Okay, so let's start with convergence. मेरा screen दिख. Oh wait, I haven't shared my screen. I guess. एक second. My screen is visible, right?
Yes, yes. Visible.
Okay, convergence, fine. I have a few examples to discuss per second. Right, so very quick recap of what a sequence is, what does convergence mean. In second, I guess. कुछ लिखा क्या? हाँ, recording हो रहा है. So a very quick recap of what convergence is, what it's मतलब क्या है. So what is a sequence? So what is a sequence? I'll be very fast with this. Convergence में थोड़ा time spend करेंगे, but not too much because the continuity नहीं है. So what is a sequence? It's essentially a function. Okay. A function defined on natural numbers. Okay. So a sequence is essentially a function defined on natural numbers. So when we say that a n be a sequence, right? What does that mean? It means essentially कि कोई एक function है, right? So इसको if we expand it, what do we get? We get a set called a1, a2, a3, and it goes off to infinity, right? So what does this mean? कि कोई so basically when I say an is a sequence, there is essentially a function, and the function is such that it takes in natural numbers as input and it spits out a real number. ठीक है? So basically corresponding to 1 there is a real number a1, corresponding to 2 there is a real number a2 which is in the sequence. So this is what a sequence is, and there are a few, मतलब it is not a hard and fast rule कि natural numbers पूरा का पूरा map करना चाहिए. So you can have a sequence such that one is left out, right? So for instance, if I define a sequence such as this, then this sequence at 1 is not defined, right? So this is still a sequence, but here all the n should be greater than 1, right? Similarly, let's say I define something like this, n minus 2. This is still a sequence, but n should not be equals to 2, right? Because then this is not defined. So these things can happen. Hard and fast rule नहीं है कि it should map from entire natural number to real numbers, and it can start, it can have some exceptions, but this is the general idea कि whatever the input to this function, whatever this n is, that should be a natural number always. Moreover, and one quick reminder that natural numbers is basically the set of all these numbers, right? So 1, 2, 3 and so on. Keep in mind 0 doesn't belong here. 0 doesn't belongs to natural numbers. This, I mean, I used to get confused with this कभी कभी, तो इसलिए I'm mentioning this, although this is pretty trivial, but 0 doesn't belong to natural number and 1, 2, 3, 4 belongs to the natural number. So that is basically what a sequence is. What do we mean when we say convergence of a sequence? So convergence of a sequence basically implies, so basically we are interested in how a sequence would behave in the long run, right? So as I make my, so I am not really interested in what happens to what is A1, what is A2, what is A3. I am interested in what is, let's say, A 10,000, A 10 crores, or A of something very big. So I want to know what happens at the extreme long run. I am not interested in short run, and I am interested in the long run. I want to know that does these values, do they get, वो किसी एक particular value के बहुत करीब जा रहा होता है, or is it diverging off to somewhere else? What does, so essentially what happens in the long run, what happens? So let's say if let's say this is my natural numbers, I'm measuring natural numbers like this, although यहाँ पर एक zero होना चाहिए, but we don't have a zero here. It starts off with, let's say, 1. There is no zero in natural numbers. Then we have a 2, we have a 3, we have a 4, and so on. And let's say this sequence, right? So let's take the very famous, very basic 1 by n. How does this behave? So let's say this is, and on the y-axis we have our real numbers, right? So on the y-axis we can have our 0, but there is no 0 on the x-axis. Anyway, so let's take this. So, एक second, someone texted. Oh, sorry, no one texted. Okay, just a second. I should do this better रहेगा. So this is a very basic sequence. Now if I put n equals to 1, I will get 1. If I put n equals to 2, I will get half. If I put n equals to 3, I will get 1/3, 0.25, and then this will be very, very, very close to 0. But I mean, it will never actually go to 0. It will actually never become 0, but it will get very, 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 very close to 0, right? So if we kind of connect this, all of these points, so what we get is essentially something like this. And from here we can say कि अच्छा ठीक है, in the very long run, whatever the sequence is, it gets very, very, very close to 0. Similarly, what other things could have happened? So let's say this is my blue sequence, okay, or purple. Sorry, really good with colors. Let's say I have a different sequence like an let's say 2 to the power n. हाँ. Convergence sequence of vectors. Okay, so let me just ask everyone, is everyone okay with notions of convergence, or मतलब long run में क्या होता है, so that we can directly get into actual convergence. If anyone has a problem, so you can unmute yourself. If they don't have a problem, then I'll actually go to convergence पूरा सीधा. I guess not. ठीक है. So anyway, the point that I was making, let me finish that. So there are going to be some sequences which are going to look something like this. They might look something like this. Oops. They might look, they can there can be multiple things, whatever. So we are interested कि long run में क्या होता है, and when we say so when we claim that an gets pretty close to some particular value a, we write it like this. And when do we say this कि ऐसा कब होगा? So an will converge to an will converge to a if for every epsilon greater than 0 there is going to be some n which is from natural numbers, such that, let's make this a capital N, such that what was it x minus a minus an minus a is less than epsilon for all n that is greater than n. Right? If any one of you has even the slightest of confusion in this particular definition, abhi bolo. Like if you don't have like a clear understanding of what this definition says, then we need to clear that first, क्योंकि उस नहीं तो you won't understand anything. Okay, so all of you I guess understand what this definition means. ठीक है. So this is when a single particular thing converges to a particular number. Now what do we mean when we say convergence of vectors? Well, this is almost entirely मतलब पूरा same ही है, right? So if I have, let's say, as a sequence of vectors defined as, let's say, Vn, which is, you know, some this entire thing is a vector, and let's say I have xn, yn, zn, right? So these three are numbers, and these particular things, they are a sequence of their own. Okay, a sequence of their own, right? So just like this is a sequence, you know, so I can consider another sequence, let's say bn, and I can put them in a vector, and the resulting thing would be a sequence of vectors, right? So there is nothing really special about this particular vector. It's just a lot of sequence or more than one sequence put together in a column vector, and that is it. Now if we say that Vn will converge to, you know, some particular value v, which is equals to, let's say, a, b, c, right? So this is a particular vector, this is not, you know, so this is a vector of sequences, and this is a particular vector, एक point है, it is in Rd, this is a point, right? Now when we say that Vn will converge to this, what do we mean? We mean that each of these components, right? So this would imply that xn will converge to a, yn should converge to b, and zn should converge to c, right? And how are we going to check if it does happen or not? Well, we'll have to apply individually this definition of convergence key to this each and every one of these sequences. And if we are able to find, you know, such n, then all of these three are converging to their respective limits, and then we can say that Vn will converge to V. So this is the basic concept. Now let me just look at कि और क्या क्या था in this. Wait a sec, I guess it was in downloads. Sequences? No. Wait a sec. I had circuit slides somewhere. This is continuity. subsequences, sequence of vectors, right? So just look at this key, right? So here also, so what do we say when we have a sequence of vectors? It's like this, right? So x1 is some vector, then x2 is again then some vector, and each one of this is given by a individual sequence, right? So sequence that we are very familiar with, each of these is just an individual sequence. So we are putting multiple sequences in a column vector and then calling it a vector sequence. That is nothing really special going on there. Now, just like we had a notion of convergence for a particular, a one-dimensional sequence, the plain vanilla sequence, we also have a similar notion in case of a multi-dimensional sequence. What does this say? Well, it says that okay, wait. Okay. So there is a different notion key. So for a single, so what was the definition of convergence for a single an? It said that for all epsilon greater than 0 there should exist some n such that an minus a should be less than epsilon. Another way of writing this is basically that for all n greater than n, an should belong to epsilon neighborhood of a. A is the point that we are claiming our sequence converges to. Now we can just copy paste this for a vector, right? So I can just say, so if let Vn be a sequence of vectors, then Vn will converge to some particular V if there exists an n such that for all n greater than n. So notice that the definition is not changing at all, right? And in fact it won't change, it will be exactly the same. Only one single thing changes, that is the notion of neighborhood, right? So let me finish this definition. So a sequence of vector will converge to a particular vector V if there exists some n such that for all n greater than n, this Vn will belong to epsilon neighborhood of V. Now here, what was the definition of neighborhood for a single particular number case? It was just ki this is basically the set of all. So this is basically this set, right? So this is basically the set of a minus epsilon, and this is a plus epsilon, right? So this open interval, open, close, open. So this open interval is what we mean when we say delta epsilon neighborhood of a. In this case, when we are talking about multi-dimensional vectors, this changes. This changes to what? This thing right here. What does this mean? कि ये जो y जो वेक्टर है और x जो वेक्टर है, इन दोनों के बीच में, so I hope you have done the recent class on linear algebra when sir was talking about the norm, right, or the distance. So this basically says the distance between y and x is less than some predefined epsilon, right? So this is what this neighborhood of V would mean. So if you are, let's say, talking about two-dimensional thing, and I am saying that my sequence of vectors converges to this particular V, then I should be able to find a cutoff point, which is my n, such that beyond that cutoff point all my Vn's should lie within a specified distance from V. right? Now what is this distance? This distance can be anything. In this case it is epsilon, right? So and I can make this epsilon whatever I want. So it's like a game, right? If you are claiming that whatever this sequence is, if this sequence is going to converge to V, if you are claiming this, then for every epsilon that I give you, I can give you an epsilon of 5. Then what you need to do? You need to find an n such that उस n के बाद, right? So such that V n plus 1, V n plus 2, V n plus 3 and so on. All of these Vn's should be, so the distance between all of these Vn's and the vector that you are claiming that the sequence of vector converges to, इन दोनों के बीच में जो distance है वो epsilon से कम होना चाहिए. So the distance between this and this vector should be less than epsilon. The distance between this and this vector should be less than epsilon. And this should be for any epsilon, right? So you gave me an epsilon of, so I gave you an epsilon of 5. So you need to find a cutoff point such that उस n के बाद इन सभी वेक्टर्स के बीच में जो डिस्टेंस है वो 5 से कम हो. उसका फिर if I again give you an epsilon of 0.000002, हाँ से
हमारी स्लाइड शो नहीं हो रही है, तुम्हारा पेन मूव हो रहा है, किसी और के साथ हो रहा है क्या, ये मेरे साथ हो रहा है.
अरे यार पहले बोलना था ना. जस्ट अ सेक. हाँ I was let me share my entire screen only. I guess I'll have to repeat whatever I just said because एक second. I was circus slide से बता रहा था मैं. Okay, so I guess none of you would have understood anything that I just said because so let me just repeat. Okay, so let me just do it here so that it is in the slide. So what I was saying was that when we are talking about vectors, so a sequence of vectors, let's say Vn, will converge to a particular point V if, now this condition is exactly the same as the normal definition that we have read already, but only one thing changes. What is that one thing? I'll say. So a sequence of vectors here will converge if there exists a natural number n such that for all n greater than n, the Vn will belong to this epsilon neighborhood of V for all epsilon. So if you kind of notice, these two things are exactly the same thing. By the way, this means कि an belongs to epsilon neighborhood of a, right? So these two things are the kind of the same way of saying this. Notation का फर्क है. So when you say epsilon neighborhood of a, what you actually mean is a plus epsilon, sorry, a minus epsilon and a plus epsilon, this interval, right? And another way of writing is that for all x such that x belongs to such that x minus epsilon is less than, an minus a is less than epsilon. So all of these three things are the equivalent, right? So कोई फर्क नहीं पड़ता है how you write it. So the definition stays the same, just one thing changes, it's the notion of neighborhood. When we are talking about, so we earlier we were talking about just a single number, right? A single sequence, a single number. So in that case, what was our neighborhood? So if this is my real number line and this is my some point a, then what is a epsilon neighborhood of a? It is basically all those points which are all those points such that कि वो point और a के बीच में जो फर्क है, जो difference है, वो epsilon से छोटा हो. So let's say all of these points, right, where this is epsilon and this is epsilon. So this thing would be my epsilon neighborhood of A. But so this is for one dimensional. This works for 1D. ठीक है. But now we don't have 1D, right? We have a real number line on the x-axis. We have a real number line on the y-axis, and then I am claiming कि this is my point of convergence. Now, okay, I guess what would be even better to actually just show you guys. Suppose this is my origin O and my vector sequence is, let's say, 1 by n, 1 by n, right? So this is a sequence of its own, this is a sequence of its own. Now when we put, let's say this is 1, this is also 1, okay. Now when we put n equals to 1, we are going to get some vector, some point here, right? So this is some point here. So arey yaar, so this is some point here. So this is my v1. Now when I put n equals to 2, I get half half, right? So some point here. So so this is my v2. Similarly, if I put 3, 1 by 3, 1 by 3, I'll get some point maybe here, some point here, 1 by 4, 1 by 4, 1 by 5, 1 by 5, 1 by 6, 1 by 6, 1 by 7, 1 by 7, and this will keep on happening, and you will get very close to this 0, 0, right? So in this case, we can see that this Vn is going to converge to 0, 0 or 0, 0, whatever. So now what does this mean? Ki Vn is going to be in some neighborhood, right? So here we cannot use the 1D notion. First, so if I just zoom this in, we cannot say ki, oh, this Vn will lie between here and here, plus epsilon minus epsilon. कोई मतलब नहीं बनता है इसका. Why will I just look at this particular direction? Or similarly I can also say कि why. So इस ये इंटरवल भी डिफाइन करने का कोई मतलब नहीं बनता है. There is no, कोई मतलब नहीं बनता है कि because Vn will lie in this interval, it won't lie on this line. तो है ही नहीं. So कोई मतलब नहीं बनता है उस तरह से डिफाइन करने का. So we need to update our notion of neighborhood. So what is a better notion of neighborhood? The better notion of neighborhood is कि a circle, right? So now my neighborhood is a circle, an epsilon. So this is my, so all of these points, right? So let's say all of these points, this is my epsilon neighborhood of the point that I am claiming, which is 0 in this case. Now let's say this particular epsilon is, let's say, 0.005. This particular, इसको ऐसा draw किया. Now this should not hold for only epsilon equals to 0.005. This should hold for every epsilon, right? So let's put numbers to these things. Let's say this was v2, this is going to be v3, this is going to be v4, this is going to be v5, this is going to be v6, इसके अंदर v7, v8, v9, v10. I hope you can imagine that. Now what I can see, so let's say there are two players, okay, let's draw one in red, one in purple. This red guy claims, so red guy is claiming that Vn will converge to 0, and this purple guy doesn't believe this guy. So now what they are going to do, now they are going to debate on this particular thing कि करता है यहाँ पर converge या नहीं करता है. So since this guy is claiming that Vn will go to 0, what this purple guy does is it gives him a value of epsilon. So it says, okay, epsilon equals to 0.005 के लिए find me an n, find me find me an n such that, so he says that find me an n such that you know vn plus 1 vn plus 2 ये जितने भी vn's हैं इन सभी vn ये सभी vn you know ये lie in the epsilon neighborhood of 0. अगर तू मेरे को एक ऐसा n खोज के लाके दे सकता है then I might consider your claim. So this red guy does some calculations and he comes up with v6. So he comes up with the value of let's say n equals to 6. Now the purple guy sees कि हाँ बात तो सही है, v7 इस red line के इस neighborhood के अंदर है, v8 भी इस neighborhood के अंदर है, v9 भी इस neighborhood के अंदर है. And this purple guy is very egoistic. He said कि नहीं ये एक के लिए तू खोज के दे दिया, और भी एक छोटा एप्सिलॉन देते हैं, let's say एप्सिलॉन इज 0.0005. ठीक है, अब तू मेरे को एक n खोज के दिखा. So what this red guy will do, he will again start to make some calculations and because now the epsilon has gone down, so this neighborhood is also gone down. Let's say the neighborhood now is something like this. Okay, so now that green thing is my neighborhood, but I can still find let's say this was v6, this is v7, this is v8, this is v9. So I can still kind of visually see कि after v9 each and every one of the member of the sequence v, they are going to lie in this green neighborhood. So corresponding to this, red guy says okay, n equals to 9. And this game goes on. This purple guy keeps giving him an epsilon, smaller and smaller epsilon. The red guy can always come up with a particular n such that उस n के बाद सारे के सारे जो members हैं वो इस epsilon neighborhood के भीतर आएंगे. And finally when this purple guy is very tired, he cannot argue anymore, he has to accept his claim that indeed vn will converge to 0. Now this is kind of this will be more clear if you consider a case where this doesn't happen, right? So if I define, so let's say if I have a sequence that looks like let's say I have a sequence like this, right? So let's kn. Now what is this sequence? This is okay, give an example of divergence sequence. Let's say 2 to the power n, 2 to the power n. And now the red guy is claiming that this converges to let's say 8 8. Let's say this is my claim. Red guy claim, right? So now let us look at कि ये definition कैसे violate करेगा, right? So let's say this is my 8 8, this is my 8 8, and what is going to be my v1? v1 is going to be, so v1 is going to be 1 1, v2 is going to be 4 4, right? Just put n ka value 2 and you will get 4 4. When you put 3 you are going to get 8 8, then you are going to get 16 16, right? Then far off 32 32, and ऐसे चलते जाएगा. Now again the same game needs to be played. Now again the red guy says कि I am claiming that this converges. He is claiming that, makes the claim. He makes the claim. The purple guy again shows up. He said, I don't believe you. I am giving you an epsilon of 10. Find me an n. So what is the epsilon of 10? Epsilon of 10 is basically the set of all points such that 8 8 और उन पॉइंट्स के बीच में जो डिस्टेंस है वो 10 से कम हो. So that is going to come around somewhere, let's say, I guess, let's say this is the 10-10 neighborhood. So let's just, so this is the 10 neighborhood of, so this is epsilon equals to 10 neighborhood of the point that I am claiming that this is going to converge is 8 8. Now the thing is ki this test fails, right? Because now the red guy cannot find a particular n. You can just try whatever n that you would choose. Can you, like, if n is greater than, if he says n is equals to 1, then for all vn's, such as for all n that is greater to 1, these vn should be in this green region, right? If this thing converges, but we can obviously see that is not true. v1 is in the green region, v2 is in the green region, v3 is in the green region. What happens to v4? It is outside this green region. So our definition says, well, this particular sequence is not converging to at least 8 8. 8 8 में तो नहीं कर रहा है. So this breaks down for a value of epsilon, right? So I mean, for one particular value of epsilon, this breaks down, and if this breaks down for even one particular value of epsilon, then this is not converging. So that was basically the intuition and the visual representation of sequences converging, diverging, etc. And so this is very easy to kind of visualize for two dimensions also. 3 dimension drawing मेरा बहुत बर्बाद है. I won't be able to do it, but there are pretty good videos on YouTube who also visualize this for 3 dimensions. But beyond 3 dimensions, we cannot visualize anything. And in that case, we need to just rely on the formula for distance to do all of this. We cannot visualize this. So let's say what is my what is this? So this thing could have been written as this, right? So in more than one dimensions, how do I write this in another form? It basically says the mod value of the norm, norm that we just did in linear algebra. Norm of these vectors vn minus v, this norm, so this thing should be less than epsilon. Now how do we calculate the norm? So I can just write this as let's say this is v11, this is v21, sorry 1n, and so on. Let's say I have m components. This is m dimensional vectors minus this. This is v1, this is v2, vm, right? So how do we calculate this norm? This is something that we did way back in class 12 or something. What we actually want to do is we want to calculate the इसका बोलने का मतलब क्या है? Very simple, in very simple words, the distance between these two vectors, the distance, simple vanilla distance, that distance should be less than epsilon. So if you remember how we used to calculate the distance, it was just square root of दोनों को माइनस करके स्क्वायर कर देना है. So vn1 minus v1 square plus vn2 minus v2 square, and so on for all the vectors. And whatever this is, उसका mod value should be less than epsilon for all vn's that is greater than some n. And this is always going to be positive, so there is no point in giving this mod, but ठीक है, कोई दिक्कत नहीं है. So that was kind of convergence of sequences. Now, is there something else? Let me think. I don't think so. So that was basically it. I don't think कि ये मतलब m dimensional k dimensional उतना कुछ सर देंगे, but whatever it comes in our exam, I don't think it is going to be computation intensive. It is going to be conceptual, मतलब सोचना पड़ेगा. Calculations I don't think are going to be heavy. So is there any more doubt regard? Okay, so let me just see कि और क्या क्या था. Okay, is this visible, this sir ka slide? I hope so. Where did it go? So this is basically, and this theorem basically says that, and this basically is the thing that I mentioned at the very onset, right? Ki if let's say if this is my sequence of vectors, and if I am claiming that this converges to this particular point, let's say v1, v2, vk, then each of these sequences, this individual sequence should converge to this particular number. This particular sequence should converge to this particular number, and so on. Right? So even in the example that we saw, this one which was converging. What was our example? 1 by n, 1 by n. So this is a sequence, and I was claiming that the sequence of vectors is going to converge to 0, 0. So now look at what happens to these individual sequences. 1 by n obviously converges to 0, and this 1 by n also converges to 0. Right? So an easier way to show that a sequence of vector is going to converge somewhere is not through this thing, not through the sheer definition. You can just show that each of these components, they are converging to some particular point, and then the vector of those point is also, and the sequence of vector is going to converge to the sequence of points. That is an easier way of showing a sequence of vector is going to converge. So that is exactly what this particular theorem says. Makes our life very easier. This is algebra of sequences. So if an converges to a, bn converges to b, then this sequence c times an, when c is a some number, that will converge to ca. If a plus b will then converge to an plus bn will converge to a plus b. Okay. और क्या क्या है? Okay, so this is important. कि if an converges to a, तो 1 by an will converge to 1 by a, and this is the proof for this theorem. And what else is there? There is nothing else. And we have some additional results here. Ki if I have a convergence sequence, then any subsequence that I can form out of this convergence sequence, that is going to converge to the same limit. And then there is the proof of that. And if a sequence has two subsequences such that okay, so if I have a parent sequence, let's say this is my parent sequence, and I form two subsequences, okay, ek xn, ek yn, and these sequences are such that if I kind of take the union of them both, then I will get my original parent sequence, right? So I am partitioning my sequence into two parts, mutually exclusive and exhaustive parts. then if both of these converge to some particular point, then the parent sequence will also converge to that particular point. So these are some results. The proof of these results I don't think is important, but we might be able to, using these things will makes our job much easier when we need to show that something will converge or something won't converge. So this was all about convergence of sequences. Any doubts here? Or is there anything else that you want me to address? ऐसा कुछ भी है? No? No. So if no, then we can move on to continuity. Right. So let's move on to continuity. Oh fuck. Okay, so continuity. Okay, so notational thing कि if an converges to a, then we can this is equivalent to saying that limit of as n tends to infinity of an, this is equals to a. Same thing, different ways of writing the same thing. So now let's talk about continuity. Okay, do you okay कुछ नहीं. So continuity. So this is basically the notion of, is a function continuous, and these we are talking about functions. So continuity of not every function. So we are talking of functions which are of functions that are defined on intervals, right? So this is just some context, not really that important. So we are not talking about any function or anything. We are talking about functions f such that functions f such that it takes in values. So the domain is some interval I, and the output is the real number, where I is a proper subset of real numbers. So we are not, so a function or a mapping could be anything. A function of mapping, I can define a function that f of cat is equals to watermelons, f of Paris is equals to pen, f of card equals to lol, anything. So this is still a function, right? So we are not going to talk about continuity of functions like this. Can someone develop an whole algebra around cats and Paris, pen, card, and etc., and then they can talk about continuity of those, but we are not doing this. So this is not what we are talking about. We are talking about functions like this, where the domain is a interval of real numbers, right? So I is a subset of real numbers. So let's say we are talking about, an example could be f of, it goes from 3 to 5 and it outputs a real number. So this is something जिसका continuity के बारे में we can discuss. So we will be talking about functions like this. It could be closed interval, it could be open interval, but it should be intervals nonetheless. Okay, now kind of story or whatever, I don't know, but when I was in class 12, there is this really good college in Kolkata, not college, university, Presidency University, most of you might have heard about it, or they used to have an entrance test, they still do. Corona का time था हम लोग का, so they removed that entrance test, and my numbers were not really good, so one of the premier institutes in West Bengal. In fact, Shundip sir is from Presidency University, which is anyway. So it is very competitive to get into, and it used to have an entrance test, but that entrance test was cancelled just for our specific 2021. 2021 the entrance test was cancelled, and the admission was done on the basis of class 12 ka marks, and I did not get very much high marks. I guess it was 80%, I don't know. I did not get in. So, but I did not know that the exam was going to be cancelled. So I kind of prepared for the entrance test for 2 years continuously, 11 and 12, and I used to have my sir used to, the entrance test ka pattern was similar to JEE mains or JEE advanced. So there used to be questions like this कि a very ugly looking function, ठीक है, कुछ एक ऐसा ugly looking function दे दिया, this when x lies in something, this when x is equals to 0, and then they used to ask if this is continuous or not. And what did I used to do? I used to, a left hand limit, कुछ आया करके, and then there used to be a right hand limit, and it used to be पूरा पेज भर जाता था, and then I sometimes I used to get the answer, sometimes I did not, and my sir told me if you do it like this, 50 marks का पेपर है, you won't hardly be able to attend one. And then I asked him, then what is the trick? How are these students doing it? And then he kind of gave me a notion of continuity, which is something that we are going to formalize now. The notion of continuity that he gave me was, if you can draw that function without lifting your pencil, then it is continuous, right? So if this is my function, this is my R2, and whatever this function is, if I can, let's say, if I can draw it without lifting my pen, no matter how weird this looks, this is continuous. But the moment I have to, let's say, lift my pencil or pen, यहाँ तक का ऐसा हुआ, and then I had to lift it up, and then it is whatever, then this is discontinuous, right? And this kind of at the time बहुत important, like बहुत अच्छा advice लगा था, but did not really help me. Like this is, anyway, that is besides the point. But the thing is that this is kind of a very basic, a very like this is something that you can explain to a 5-year-old. But now the point of formalizing this concept comes in. How do you formalize this? So let us first look at what does the actual definition says. A function f such that it goes from I to R is said to be continuous at x is equals to c if for all epsilon greater than 0 there exists a delta greater than 0 such that f of x belongs to this epsilon neighborhood of f of c imply sorry ulta such that x belongs to what x belongs to epsilon neighborhood of c implies f of x belongs to delta neighborhood of f of c. This is there is a slight inaccuracy. Actually, you don't say it like this. You say it like x belongs to I intersection b implies f of x will belong to sorry, you know, and then this. So there is I intersection. This is not so useful for us. I mean,
And
huh?
x belongs to delta neighborhood of c, not epsilon neighborhood of c. Fx belongs to epsilon neighborhood of f of c.
Repeat that again.
X belongs to delta neighborhood of c, not epsilon neighborhood of c. And fx belongs to epsilon neighborhood of f of c. We have written it.
Okay, it doesn't really matter, right? Because they're like symbols. There is, I mean, I can just replace this and I would be having the same thing. Doesn't really matter. So let's, okay, so this is actually a good point. So let's just get rid of epsilons and deltas, because this is a thing, right? Because you study a definition one way and then if someone writes it the other way, all your preparation gets messed up. So let's just ditch epsilon and delta. Let's just say, because this is something that I suffered myself, like so because sir was doing like that और book में उल्टा लिखा हुआ था और मेरा दिमाग खराब हो रहा था. So a function f is going to be continuous at some particular point x equals to c if for all a greater than 0 there is going to be a b such that x belongs to b neighborhood of c should imply f of x belongs to a neighborhood of f of c, right? So कोई epsilon नहीं, कोई delta नहीं, like this. Now if you can understand what this definition means, like nice, very good, but I don't understand this. I mean I did not understand this even if after I looked at it thousands of times. So let's try to understand what this, you know, in grammatic or diagrammatically means. Now to understand these things we need to always look at two things: one when the definition holds and one when the definition doesn't hold, right? So let us first look at when the definition holds, or when, right? So let's say this is some function and we are claiming that this function, so let us, this is some particular c. Okay, let's I can just हाँ ठीक है, फर्क नहीं पड़ता. So let us this is some function f and this is some particular x is equals to, this is some c and this is some you know, f of c. Now let's see what happens, now let's see what my definition tells me. My definition tells me ki, okay, so don't look at this graph, or I mean it is impossible to not look at this graph, but kind of get rid of the idea कि ये function, so be distrusting of everything, you know, just because दिख रहा है ये continuous है, don't believe कि ये continuous है. Let us go by the definition. So our initial idea is कि this is not continuous, okay, and we'll only kind of convince ourselves कि ये continuous है only if when this definition holds. Now what does this definition say? कि for any given a, okay, so this is given, a is given. For any given a, I need to come up with a b, right? I need to come up with a b such that this thing holds. So let's take a. Okay, ठीक है, let's take a is, let's say 5 or 6, whatever. Now so it basically says that there should be a b such that if x belongs to this b neighborhood of c, then f of x should belong to a neighborhood of f of c. So let's first draw this a neighborhood of b of c. So this is, you know, f of c plus a, and this is f of c minus a. So this is my a neighborhood of f of c. Now I need to find, so this is my this, right? अब बोला क्या है कि, अब बोला है कि I need to find a neighborhood of x, I need to find a neighborhood of x around c. So I need to find, you know, a neighborhood around c. So it can be this neighborhood, it can be this neighborhood, or it can be any neighborhood. I need to find a neighborhood around c such that कि उस neighborhood के अंदर x belong करेगा, तो f of c इस blue neighborhood के अंदर belong करेगा. So can I find such a neighborhood? Well, yes, I can, right? I can take this to be my neighborhood. Let's use what color? Pink. Let's use pink. You know, this is a suitable neighborhood. Okay, maybe not that. Let's say this is my suitable neighborhood. Right? So this is my, so this is something, right? So this is c plus, let's say c plus whatever, let's say a bar or a1, and this is c minus a1. So now see if this thing holds or not. Ki I found, okay, so let's not name it as a because then we'll get confused. Let's name it as b1. So this is, let's say, c plus b1. This is c minus b1. This point. Now let's see if this implication holds or not. Right? What does this implication says? It implication says कि अगर x is whatever the neighborhood that we came up with, अगर x उस neighborhood में belong करता है, तो f of x इस neighborhood में belong करना चाहिए. तो let's look कि वो हो रहा है कि नहीं. Let's take this particular value inside, you know, that neighborhood. So okay, so what is this? This is basically my b equals to b1 neighborhood of c, right? So we needed to find a value of b, right? So the value of b that we are claiming is, let's say, b1, right? So now if we choose any value of x in this neighborhood, the functional value of that point should lie in this blue neighborhood. So let's see if that happens or not. If I pick this particular value, then I can see that हाँ वो ये blue neighborhood के अंदर lie कर रहा है. Fine. let's pick this value. So this is the point that we came up with, this is the point we came up with. So it is pretty obvious to see ki in this interval, if we take any value of x, the corresponding value of f of x will lie in this neighborhood. That satisfies our definition. So yes, this function is indeed continuous. So now we are convinced. Thank you. Just a sec. Okay, Ruby, did you like hear what I was saying here, or did you miss something? Okay. Okay. So indeed this function is continuous, right? Because like this a was arbitrary, right? So I choose this a randomly. I did not माने कुछ particular नहीं, ये a हम कुछ भी choose किए थे, and for that a I was able to come up with this particular neighborhood. I was able to come up with this particular neighborhood. Now the question is, and that hold, this implication held. Now the question is this the only neighborhood that is possible? No, right? I can, let's say, pick a neighborhood like this, right? So I can have this neighborhood too, this green neighborhood, and the corresponding values of f will still lie within this a neighborhood of f of c. So there is no unique value of this particular b. There can be multiple, right? So that now, if I know that b1 is such a neighborhood which satisfies this, then obviously if we consider a smaller neighborhood, ठीक है, कि अगर वो b1 के लिए होल्ड करता है तो उससे हम एक छोटा नेबरहुड लें तो ऑब्वियसली वो उसके लिए भी होल्ड करेगा. वेरी क्लियर फ्रॉम द ग्राफ, राइट? सो इफ दिस डेफिनेशन होल्ड्स फॉर अ b equals to b1, then it will also hold for b that is less than b1. That is for sure. कि अगर वो इतना बड़ा एक नेबरहुड के लिए होल्ड कर रहा है तो वो उससे छोटा नेबरहुड के लिए भी होल्ड करेगा. बट द अदर वे इज नॉट ट्रू. लाइक इफ वो ये नेबरहुड के लिए होल्ड कर रहा है तो वो इस नेबरहुड के लिए नहीं भी होल्ड कर सकता है. सो this is something that Sandeep sir asked, right? कि if this is my epsilon, if this is my delta, then is this the only value of delta that holds? Like, no. So if I know that if this condition holds for a particular b1, then it will also hold for any condition for any neighborhood that is smaller than b1 neighborhood. So I hope this was clear. Now ये तो ठीक है, समझ में आ गया. But then how, using this, how do we say that this is not, a function is not continuous? How do we say that? So let us try to look at that. Now let us consider a discontinuous function, right? This is my C. Again, I have a arbitrary so for any given a, right? So for any given a neighborhood of f of x, so let's first draw that. Maybe I consider this. Okay, so so this is my a neighborhood of f of c. What is my f of c? So let's say it is not defined here. It is, let's say, यहाँ पर defined है, right? So this is my f of c. Now can I find a neighborhood around C such that all those points. Oh, okay. One thing that I forgot to mention. So whatever this is, this should hold for all A, right? So यहाँ पर like we were considering this blue interval, this blue thing. There should be nothing special about this. Now, if I just remove this and if I give another interval like this, then again we need to be able to find a b1 or b2 whatever. So this should hold for all values of A, and we need only one value of B. So this should hold for all values of A, and we should only be able to एक भी ऐसा अगर neighborhood मिल जाता है around C such that this holds, then we are done. But this should hold for all A. बस एक A के लिए hold करे तो it is not done. This should be able to hold for all A. Now let's look at this, because that point is important to show why discontinuous functions are indeed discontinuous according to this definition. Now let's consider this function, the A neighborhood. The A neighborhood that I have considered is this f of c plus A. This is f of c minus A, right? Again, यहाँ पर like we can easily come up with an epsilon or we can come up with a neighborhood around C such that for all x that belongs to that neighborhood of C, the corresponding f values will be in this, right? So this is very easy to see. We can, let's say, pick a interval like this or a neighborhood like this, right? Now obviously इसके बीच में अगर हम कोई भी x का वैल्यू लें तो वो इस ब्लू नेबरहुड के भीतर ही रहेगा, तब तो ये कंटिन्यूस हो रहा है. That is a very valid question or very valid point कि तब तो ये तो कंटिन्यूस हो रहा है, because you gave me a arbitrary A, I was able to find a neighborhood around C such that this implication holds, right? Because all of these points will lie in this blue neighborhood. So where is the problem? The problem lies that this is a very specific value for A for which we can do this. If instead of considering this particular neighborhood of f of c, if we consider, let's say, this neighborhood, or sorry, that is very absurd. If we consider, let's say, this neighborhood, if we consider this neighborhood around f of c, so let's say I call this, let's say, fc plus a bar and fc minus a bar. If I consider this value, if I consider this particular neighborhood around f of c, then can I find a neighborhood around c such that the implication holds? Well, no. No matter what you choose, let's say if you take this particular so let's say if you pick this particular interval, some of the values are in this blue, in this region, some of the values are, but what happens to all of these values? All of these values, ये सभी ब्लू वो पर्पल नेबरहुड के बाहर लाई कर रहा है, राइट? सो और if I make this very clear, बहुत कुछ draw हो गया है, let's just remove a lot of things. Let's remove this, let's remove this. Right, so, and this is my f of C, and this was my blue neighborhood. So when I say blue neighborhood, ki f of C, f should lie between, f of x should lie in this jagah. So that is what I mean when I say blue neighborhood. That is what I, so this is the blue neighborhood, right? So this is the thing that I want. So now can you find, and this thing is my C, right? Now can I find a neighborhood around C such that all the values of x, such that x is in that neighborhood of C, or for all source x, the f of x lies in this blue neighborhood. Now can I find? No. And you can try doing this. You won't find. Let's say you consider, the same neighborhood. If you consider this neighborhood, then यहाँ तक का तो ठीक है, मतलब f of c तक का तो सब ठीक है, ये वो blue neighborhood पे आ रहा है. But what about these points? If you take any x here, you are out of this blue neighborhood. Your implication doesn't hold. You want to pick a smaller neighborhood? Fine, do that. See what happens. Let us just remove this. Let's pick a smaller neighborhood. Let's consider this neighborhood. Now what happens? Till these points, तो ठीक है, the implication holds. But what happens to these points? The implication doesn't hold. It is outside this blue thing, right? So this is indeed what we were looking for, the definition that we were looking for. So the notion है ना कि the notion की draw करने के लिए pencil नहीं उठाना पड़ेगा, that is mathematically conveyed by this definition. Is this clear? I need to either text it out or say if this is clear or not. Okay. Okay, so this is clear. Okay. It is almost 6. Do you guys want to continue? I can show you, I can do a few examples, or we could do this another day. Because I too don't want to sit. मेरा 7 बजे से एक दूसरा क्लास है. I'm 1 घंटा चिल मारने का प्लान है मेरा. So, but if you guys want, I can show you a few examples. No issues. अनम्यूट करो भाई, क्लास कॉलेज का क्लास थोड़ी चल रहा है.
नहीं, तुम जैसे कंफर्टेबल हो वैसे तुम फिर कर लो, कोई बात नहीं, कल ले लेना क्लास, अगर कल या परसों में.
ठीक है. So if that is ठीक है, that also works.
हाँ, लेकिन मेरी तरफ से होती है और
चिल करो भाई, चिल करो, कोई दिक्कत नहीं.
Okay. Okay then, so we'll do few more classes weekends में. एक तो statistics का 5.6 ख़त्म करना है, and रोहिणी मैम से हम पूछे कि वो sufficiency वाला पार्ट कितना करना है. तो मैम said कि whatever is in her slides that is more than enough, but if you want to do more from the book you can do. So let's देखते हैं. पहले 7.6 ख़त्म कर लेंगे, टाइम बचा तो sufficiency का पोर्शन थोड़ा कर लेंगे, नहीं बचा तो next week कभी. And we'll have one, I guess 2 more. Where are the slides? Good question. I'll have to ask a few people who are very active in DSE unofficial, DSE official, बहुत टाइम है उनके पास, तो वो खोज के दे देंगे मेरे को. Once I get them, I'll share them in the group. And Yeah, so I guess we'll have to do one more class for maths. Okay, first let me stop the recording.